Okay, in this video, we're going to talk about the length of a circular arc. But with this, we get a formula that connects together radians and the distance around the outside of a circle and the radius. So we're going to use this mostly to define what a radian is. So as we take a look at this, the length S of an arc that subtends a central angle of theta radians is given by this formula, S equals R times theta. So I know those words sound confusing to a lot of students at first. All right, the length S of an arc that subtends a central angle. What we're talking about there is we're talking about the distance around the outside of the circle. So S is like the pizza crust going on here, and the distance, how many inches or feet or meters or miles it is if you walked around the outside here, basically. And then R is the radius. And then theta, what theta is going to be is it's going to be the angle on the inside here. All right, so with just a little bit of rearranging of our formula, you can see what happens on this. What they've done here is they divided both sides by R to isolate theta on one side by itself. So if you divide both sides by R, move that to the other side, we get theta equals S divided by R. And it is important in this formula that theta is always going to be in radians. So if you ever plug into this formula, make sure that theta has to always be in radians. But to define kind of what a radian is, let's take a look if the distance around the outside, S, and the radius of our circle were the exact same. All right, so S equals R. Then based on this formula, what we had up here, you could say, well, I can substitute in with this S. I can put an R in that spot because they're supposed to be equal, and you would get to R over R. Well, if you have R over R, same thing, numerator and denominator, that makes a 1. And remember, theta is in radians. So if you want to kind of visualize how far around a circle is 1 radian, well, this would be 1 radian in this first illustration, where the distance around the outside would be exactly the same as the distance for our radius. 2 radians would be if this distance around the outside was twice as far as our radius. And on the right-hand side, you can see we have 3 radians kind of outlined here, 4 radians, 5 radians, 6 radians. Now it takes 2 pi radians to go all the way around, 1 full revolution all the way around the circle. All right, so 2 pi radians is 1 time all the way around the circle. You may also recall that it would be 360 degrees to go all the way around the circle. So 2 pi radians is equivalent to 360 degrees, or half of each of those. We could say half of 360 degrees would be 180 degrees, is going to be equivalent to a half of 2 pi, which would equal pi radians, 1 pi radians. So this is the conversion factor that I like utilizing when we convert back and forth between degrees and radians, or vice versa. 180 degrees equals pi radians. Okay, so we're going to be using radian measure as well as degree measure along the way. We want to get comfortable switching back and forth in between these two different measures, kind of like when you have more familiarity with like the Fahrenheit system for temperature and the Celsius system for temperature. Being able to convert back and forth in between these two different units is actually pretty convenient. We're going to be using both degrees and radians throughout the rest of the class. So we want to get comfortable with connecting them together. All right, good luck on this. See you.